Your heart is racing. Your palms are sweating. You didn't choose any of this. But the real answer is far stranger than you're just scared. Right now, somewhere in your skull, a tiny almond-shaped structure just hijacked your entire body. It didn't ask permission. It didn't wait for your thoughts to catch up. It just acted. This is your amygdala, and it's been running the show since long before you were born. Here's what most people get wrong about fear. They think it starts in the mind. It doesn't. It starts in the body, milliseconds before your conscious brain even knows what's happening. Neuroscientist Joseph Ledoux spent decades mapping this exact pathway. He found that a threat signal can reach your amygdala through a shortcut, bypassing your thinking brain entirely. Your body reacts before you even know why. Think about the last time you jumped at a shadow. Did you decide to flinch? You didn't. Something older than decision-making took over. That something has a name. Physiologist Walter Cannon called it the fight-or-flight response back in 1915. He watched animals under threat and noticed the same pattern again and again. Blood rushes to the muscles. Breathing quickens. Digestion shuts down completely. Your body is making a bet. It's betting that surviving the next 10 seconds matters more than anything else you were doing. But here's the twist almost nobody talks about. Fight and flight aren't the only options. There's a third one, and it's older than both. Freeze. You felt it. That moment when your legs won't move. When your voice disappears right when you need it most. When you stand frozen, watching danger unfold, unable to do anything at all. For years, this looked like weakness. It isn't. Trauma researcher Peter Levine studied this response across species and found something remarkable. Freezing isn't failure, it's strategy. Picture a rabbit caught by a predator. Fighting back means certain death. Running means the predator's chase instinct kicks in harder. But freezing? Playing dead? Sometimes the predator loses interest. Sometimes it lets go just for a second, just long enough. Your freeze response is millions of years old, borrowed from prey animals who needed exactly this trick to survive. So why does it feel so shameful when it happens to you? Because modern life almost never asks you to freeze. Nobody's about to eat you in a meeting. Nobody's stalking you at a dinner party. Your fear circuitry doesn't know the difference between a predator and a deadline. It fires the same ancient alarm for both. This is where things get strange. Your amygdala can't tell the difference between real danger and remembered danger. A study environment, a blinking cursor, an unread message from your boss. To the oldest part of your brain, these can trigger the exact same cascade as a lion in the grass. Have you ever felt your stomach drop before checking an email? That's not an overreaction. That's 10,000 generations of survival wiring, misfiring in a world it was never built for. Consider what your ancestors actually faced. A rustle in tall grass could mean wind. It could also mean a predator crouched low, waiting. The humans who survived weren't the ones who calmly analyzed the odds. They were the ones who reacted first and thought later. Fear that arrives too fast to reason with wasn't a flaw. It was the entire point. Neuroscientist Joseph Ledoux later revised his own thinking on this. He argued that what we call fear as a feeling is actually a separate process from the body's survival response. The racing heart happens first. The conscious experience of being afraid comes second, almost like your mind is explaining a decision your body already made without you. That reframes everything, doesn't it? You don't feel afraid and then react. You react, and then you feel afraid, as your brain scrambles to make sense of what your body already did. So, what actually happens, step by step, in those first few seconds of terror? First, your amygdala sounds the alarm. This happens in a fraction of a second, faster than you can blink twice. Second, your hypothalamus activates what's called the HPA axis, flooding your bloodstream with adrenaline and cortisol. Third, your body redirects resources instantly. Blood leaves your digestive system and floods into your large muscles. This is why fear can make you feel nauseous. Your stomach is quite literally being starved of blood so your legs can run faster. Fourth, your pupils dilate, letting in more light, widening your field of vision. Fifth, your hearing sharpens, sometimes so much that ordinary sounds feel deafening. Your body isn't malfunctioning during a panic attack. It's doing exactly what it evolved to do, just in a context that doesn't call for it anymore. Here's the part that should genuinely unsettle you. This entire system runs on prediction, not reality. Your brain builds a model of threat based on past experience, then reacts to that model faster than it can check whether the model is even accurate. Researcher Robert Sapolsky, who spent years studying stress in wild baboons, found that this same mechanism, when triggered constantly by non-physical threats like social status or financial pressure, can wear the body down over months and years. The stress response built for a 10-second sprint from a predator was never designed to run for an entire fiscal quarter. So when you feel your jaw clench during a tense conversation, or your chest tighten before a difficult phone call, you're not weak, you're not broken, you're running software installed roughly 200,000 years ago, in a world of teeth and claws now trying to process a passive-aggressive text message. What can you actually do with this? You can't switch off the amygdala, nobody can, but you can work with the body instead of against it. Slow, deliberate breathing signals safety directly to your nervous system, cutting through the alarm faster than any thought could. Naming the emotion out loud, even quietly to yourself, has been shown to calm activity in the amygdala, almost immediately. Your ancestors didn't have language sophisticated enough to do this. You do. That's an advantage they never had. Next time your heart pounds for no obvious reason, pause before judging yourself for it. Ask what your body might be reacting to that your mind hasn't caught up with yet. Because that racing heart isn't a glitch. It's a message sent from deep inside you, from every ancestor who lived long enough to pass down exactly this wiring. Somewhere, a rustle in the grass once meant the difference between having descendants and not having any at all. Your heart is racing, your palms are sweating, and now you finally know why.